Okay, 2.3, product rule coming from power rule from 2.2. Have both definitions of the product rule right here. We have it in the Newton notation and the one that you dislike and probably won't use. But we're going to see how it comes in handy for communication in this section right here. So what this means, if you have a polynomial function and it is a function multiplied by two functions, or two functions multiplied by one another, the derivative, f or p prime, is this. So I can't just find the derivative of x and I can't just find the derivative of f and the derivative of g and multiply them. That's not going to work. So what I have to do is I have to find the derivative of f multiplied by g. Then I got to find the derivative of g and multiply it by x. And this is the product rule. Think just find the derivative of one, multiply by the other, find the derivative of the other, multiply it by the first one. That's it. Because it's plus, the order doesn't matter. Okay, but stick to an order because when we get into quotient rule, order matters because it's going to be subtraction. So the difference between the two could lead to problems. Likewise, in this notation, if u and v are two functions, then the derivative of uv with respect to x is going to be the derivative of u times v, like u prime times v, same thing, plus the derivative of v times u, same thing. Okay, so let's go right into an example of applying the product rule. Differentiate, I heard a question already, what's differentiate means? It means find the derivative. Find the equation of the slope of the tangent. If we want to find the derivative of this, I'm going to use this notation because I want to show, you know what, I'll use both. I'm going to say h prime at x is equal to the derivative of this first one, which is just 2x minus 3, times the second one, plus the derivative of the second one times the first. Just like that. Doesn't matter if this is backwards, right? I always put monomials in the front. Okay, and now I can expand these guys. That's a 2x6 plus 4x minus 3x5 minus 6 plus 5x6 minus 15x5. Collect some like terms. Always start with the highest power. I got 7x6, 12x5s, negative 12x5s. I lied, negative 18x5s. Nothing else, just x's. 4x. Therefore, h prime at x equals 7x to the 6, blah, 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 blah. If you see mistakes, guys, call them out, please, even though we're on a video. Okay, so I like the first step to be in this notation sometimes because look what you can communicate in that notation. I can say h prime at x is equal to, or I wouldn't use prime, sorry. So I can say dh over dx equals the derivative of the first one. So I can say the derivative of this times this, sorry, this is over dx, x5 plus 2, plus the derivative of this with respect to x times the first one. Okay. And what this does is just like, it kind of rewrites the question and just reminds you what you have to find the derivative of. Now I just find the derivative of that, and that's your next step. Find the derivative of this, that's your next step. Okay, there's no way we really can say, you know, this prime. We just kind of derive it right away, which in my opinion for this question is easier to just derive it because it's a pretty easy step. Okay, but notice the two notations, and then this would just fly right into this step. Trust me, when it gets way more complicated and we incorporate other rules, this communication will help you get through it. Okay, we're gonna do this one. We've got trinomials, two trinomials multiplied. Find the value, of h prime at -1 for this function. So first thing, I have to find h prime before I plug in -1. So take a look at the question. H prime at x equals derivative of this. Remember power rule times this. I'm already foreseeing being annoyed that I gotta like multiply these together, right? plus the derivative of the second one, 4x plus 1, times this. What do I do from here? Any advice?
Did you expand?
Absolutely not.
The 2x squared plus x plus 6, you can factor it, and then just...
Wrong again.
That's right, so it's literally right.
Okay, both answers are correct, but there's no reason to do work over here if I don't have to. The question is asking me to plug in -1, so plug in -1. Maybe if it was a 7, I wouldn't, but it's a 1. That's easy to plug in. As soon as you have the derivative, even if it's not simplified, you're dealing with a 1, plug it in. So this is a 15 times 1 plus -14. I'm kind of just ripping through it here. That's a 2 minus 1 plus 6. That's a -4 plus 1. That's a -5 plus 7 plus 3. Okay, so I'm just putting -1 into all the x's. This becomes a 1, gone. This becomes a 7. -3 times 5. 7 minus 15. -8. Therefore, h prime at -1 is -8. Okay, so yeah, we could expand sometimes, right? Sometimes it's not going to ask for, the derivative at -1. So you're going to have to expand and simplify. But look for the opportunities where you don't have to do work, right? And always take it. Okay, next in product rule, we have power of a function rule. So some functions in their entirety have powers, right? It's not just like x to the power of 4 or 5x to the power of 4. It's a whole function to the power of 4. So if you have a function that is a function to a power, the derivative of that function, f prime, you bring down the exponent like normal. I forgot the n minus 1. You bring down the exponent, you subtract 1 from the exponent just like it's a regular power rule, but you have to multiply it by the derivative of that entire function on the inside. Really, really straightforward. So we saw before when we did power rule, we'd have to expand this like 6 times. We're not going to do that, right? In section 2.2, if this was a 2, sure, we'd expand it because we don't know product rule yet, and we solved, but now we have a different strategy to get there quicker. So if I want to find h prime at x for this function is a function to a power. So what I have to do is say, well, h prime at x is 6 times the function times the derivative of the function. Yes, sir.
To the power of 5.
Forgot it there and here. Can I simplify anything here? Nope. If there was like maybe a factor in here, I can pull it out. I can combine it with the 6, but there's no reason to factor anything out. Okay, this is my final answer. One step. What? How is this so easy? I don't know. Okay, in case you thought it was easy, don't worry. We got rational functions here. Okay, rational functions can be attempted in multiple ways. The way that we're doing today, which is the way you will be practicing over the weekend, and then on Tuesday I'll show you a better way to do rational functions. So we want to do this rational function, it's a ratio of two functions, using the product rule. First and foremost, if I know product rule, I have to change this into one line. Like that. Okay? And now this is just product rule. But be careful because this is the power of a function, a different function. Right? We just don't use power of a function when it's a 1. It's not necessary. But if it's anything other than a 1, we have to do something. So f prime at x is going to be the derivative of this times that plus the derivative of this, bring down the 1, lose 1 on the exponent, times the derivative of inside the brackets, that's just what we did here, so I'll say that again after I finish, times the other function. Okay, so I'm going to talk about this one. The derivative of this is 2, times this, done, plus sign, half the question's done. This side, I have to find the derivative of this, and that's a big deal right now. That is this entire thing. So it's power of a function. I bring down the -1 in front. I write down this. I lose what power, and then I multiply it by the derivative inside the function. And then I still have to multiply it by this. Okay, generally speaking, there's going to be a lot of cleanup when you're doing stuff like this. So use cleanup if you see it and if you want to. I would recommend it. So what do I mean by that? I'll show you. This monomial, put them in the front. This is just -3, 3x minus 1, -2, 2x plus 5. Okay, no reason to have a plus sign if it's minus, and everything's going to be multiplied in front of here. Now, if you zoom out over here, I have two sides of an equation. I don't like things in non-factored form. This is kind of expanded. I want factored form. So what I'm going to do is I'm going to find something that both sides have in common. They both have a 3x minus 1 in common. Okay, just remember if I have like 2x3 minus 3x 2 times y, this is like mimicking this. If I'm factoring out an x, which one am I going to pick? I'm going to pick the one with the lowest power. x2 gets factored out. This becomes 2x. This becomes 3y. Common factoring. That's what I'm doing. I'm taking out a 3x minus 1 to the power of -2 because -2 is the smallest power. So I pull out a 3x minus 1 to the -2. And I love using square brackets here because a lot's got to happen.
Okay.
Now, look at this side. If I take out a 3x minus 1 to the -2, I'm left with a 2, 3x minus 1. How? I got you.
Yeah,
This is what I'm doing, right? I'm dividing this by the common factor. -1 minus -2 is +1. This equals 3x minus 1. You're going to see that repeatedly over and over again. It's kind of like the opposite of what you're thinking because they're negative exponents. But do this just to make sure, and you should get the answer. First side of the question, done. Now I got to work on this side. I took out a 3x minus 1 to the -2, so that's a 1. So I'm just left with 3, 2x plus 5, and that's it. I have one factor, and now I have something else that I can expand and factor and blah, 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 blah. Okay, so this is still a 3x minus 1 to the -2, and I can clean up some stuff over here. I can say this is a 6x minus 2 minus 6x minus 15, mistake alert. Bye-bye 6x. I'm left with -17. I don't give answers with negative exponents. So my final statement is going to be f prime at x is -17 over 3x minus 1 squared boxed. Okay. Negative exponent means it is on the denominator. I'm multiplying it by -17, so this is my final answer.